All right, thank you everyone for joining. I just wanted to start by asking a question. When was the last time you were invited to a root cause analysis meeting or participated in one and you were excited about it, right? So in my experience, these aren't fun meetings at all, right? Most of the times people would come in with a very defensive mindset or a defensive approach, thinking it's a blame exercise. And to add to that, right, by the time the chronology of events is established, a long time has passed. You're having meeting burnout, and you do not have enough time to focus on the improvement actions, right? To top it off, it's just one defect you did the analysis for, or 4, 5, maybe 10 people came into a room for one defect or one incident, right? So it is time consuming. So what I wanted to talk about today was a program I implemented at my workplace, which helped us remove these negative perceptions of RCA. So I'm Amol Patil. I work at Mimecast. It's a cybersecurity company focused on threat detection for emails and email attachments. And I'm very passionate about climbing. So like all root cause analysis, the goal really was on defect prevention and incident reduction. And to go about this, right, the thought process was that there are many stages during a software development cycle where a bug could get injected or detected, right? Optimally, all of us would like to have a bug detected as close to the point of injection as possible, right? But that is still what we would call defect containment. So the focus wanted to be on defect prevention in this organization. So I just tried to put together a definition saying, okay, how do you prevent defects? What's the textbook definition of it, right? So you identify the common causes and you focus on relevant processes that you think should be changed to prevent the defect from recurring, right? So what's the focus on? The focus is really on what we already know, right? So the technique that we're using is called orthogonal defect classification, right? So ODC was started by Ram Chillarage at IBM way back in 1990. He still maintains a very nice website. You should look it up with his name and ODC. So he created this new methodology where you can take your defects, and you can characterize them, and then you translate it into process defects. I was very impressed by what he had presented in his original paper, and I thought I could apply it to my organization. So before we do that, right, what is ODC, right? Or orthogonal defect classification is, it's a process in and of itself, right? It focuses on profiling defects, right? And defect profiling uses historical data. Basically, it could be ancient history, it could be recent history. What's done is done. What can we learn from it, right? So the basic principles of ODC start by the statement saying a defect in the software is a defect in the process. Makes your RCA or root cause analysis meetings very simple. It's not a blame exercise anymore. Everybody's there to improve the process. It was very cost effective to do this, and I'll show it to you in some of my later slides. What it does is it already uses your existing system of record that you have for capturing defect data, like Jira or some other system that you have, right? You're already collecting the data. This process just enhances that data collection. You can make data collection real time, right? Everybody's in Jira. You're putting in your estimates. You're putting in comments, details. When you're closing out your tickets, you're picking and filling up certain fields. So you add some additional fields and the real-time data collection is virtually free. Right? You can start small and you can go as big and as wide and as complex as you want, right? So you can start with defects that are found in the field, like incidents, and then you can, adopt it for your in-process defects, right? We also started to use a lot of these through analysis for predicting quality, right? And when can the project be completed? It's very simple. You can use it for however you think it could fit to your organization, right? Now, orthogonal defect classification is basically defect profiling and creating a lot of other defect data that you can use in a lot of various metrics, right? And what kind of defects are these? Maybe you're already capturing it, maybe you're not, but you can start by including these, like origin, what business routine, what triggered the defect, what was the trace on the defect, what was the volume of data at the time of transaction when the defect occurred, what's the frequency, when was the code last modified that resulted in a defect, what's the history of this particular functional area, right? What were the steps for the end user to get to that point of the defect, right? You could also start capturing why is this happening, right? And then maybe capture a initial root cause analysis for this, okay? What we implemented was we started small with a very simple defect classification scheme. We captured 4 attributes for the defect: the origin, the trigger, the type of defect, and the fix category, right? Origin, everybody knows where it originated. Trigger is basically it's not the defect itself, but it's the event that made the underlying fault in the code a failure, right? So we want to capture that, the type of defect, of course, and how did we fix it? So sorry about the eye chart, but where are we capturing these fields from, right? So the origin and the trigger is captured from the field defects in Salesforce, right? So was it in customer prod, or was it in customer non-prod, or was it in the engineering non-prod? What kind of triggers were there? Like, was it data that caused the trigger? Was it a transaction, configuration, volume? So there's a ton of these that we can capture. These are basically tailored to the healthcare company that I was working for. So we looked at all the historical information and created categories like this. It was very simple to implement. It took us maybe a week to put it into Jira, right? And all those of you who have worked with Jira can see that. You can add tabs to the field, to the main section. And we created a tab called root cause analysis and created fields with pick lists and drop-down options. So you could choose one of these. So as you're closing your ticket, as you've fixed a bug, and you know the bug is fixed, you've tested it, and now you want to move ahead and close the ticket, you would start selecting these options in there, right? One of the additional fields we were also tracking in this area was data characteristics. So this is a free form field. If you felt like this happened while you were working with certain type of data, or you want to record it, go ahead and you can do that. So we can use that later for analysis. After you fill that out, you had to fill out the actual root cause disposition. There were 5 choices made available. Is it the architecture gap? Is it an engineering gap? A requirements gap? Okay, was it a performance engineering team, that something they should have done? Or was it the technical writing team, instructions not clear? Is it something for them? Along with the root cause, we're capturing some kappa fields, like why did you choose that root cause? What's your reasoning behind it? what's the preventative improvement and what's the detection improvement. We made classified those two as clearly distinct things because, as I said earlier in the slides, we wanted to focus more on prevention, on bug avoidance. And then, of course, who did the root cause. So no longer, root cause analysis is no longer a meeting. You're not doing 5 whys or fishbone. It's the person who's filling this out is using this data. And how do we guide them, right? How do you put together a root cause analysis disposition, right? You want to say, where is the problem and who should be fixing this eventually, right? So there was a chart put together called the hierarchy of controls to basically ask the question, right? How could these type of defects be prevented in future, right? So you would have to choose one of these values, which was a best fit for what you were trying to do, right? And the focus should be on, most effective. If you're talking about a root cause disposition and saying, I need to train my engineers better, right? Anything to do with training or policies is not as effective in the long term for bug prevention because it focuses on an individual. Individuals come and go, right? So we do want to focus on things in the software itself, right? So what can we do? What type of a defect was it? Was it a defect that made it easy for our customer to do the wrong things and created a whole bunch of problems? So, all right, let's think about that and how to improve it. What can we think about eliminating the error altogether, right? What do we have in terms of self-healing? What do we have in terms of auto-healing built within the program? What do we have in terms of telemetry that can be put in so we can get advanced warnings, right? To not even have to reach that defect error. When you are doing root cause analysis, right? And you are, let's say, 10 Scrum teams and everybody's doing this, you're likely to get a lot of different types of root cause analysis, right? It won't be consistent. So in order to be consistent, right, we again put together another template that would help whoever was the lead documenter of the root cause or whoever was responsible for putting it in would have to talk about, look at the previous hierarchy of control chart and say, okay, start with the template. Going forward, as part of the process, which role will take what action and what would the improvement be, right? And the improvement was coming from the previous one, right? So you could think about, your story breakdown, high-level requirement refinement. It could be triaging process. It could be code reviews. It could be unit testing. Again, we want preventative improvements to be focused on the time where the ticket that you're working is considered complete, right? So code reviews, unit tests, design approaches, refinement, even all the way back to requirements. If you can, go all the way back and make sure you have everything in place to do this. The other thing about process changes is governance, right? So how do you check for adherence? Again, we tried to put together a note in our root cause analysis talking about we will measure adherence by using this tool. So all of this was collected real time by through Jira records, and whatever you're entering in there, the managers, the engineering leaders would then use it, to check for adherence. On similar lines, detection improvements, right? So where do the test engineers, quality engineers, SDETs, software development engineers in test would come into the picture is on your detection side. So anything you do to test, right? Testing, you do testing to confirm bugs or absence of bugs, right? So what are they doing in their role to check this? So going forward, they can focus on unit level tests, integration level tests. Are they using any test design or automation framework if they're writing stories, if they're doing test plan writing, ad hoc testing, if it's related to data migration, software upgrade, if it's related to test approval, test review, system level testing, end-to-end testing, if it's a quality criteria that you're measuring, maybe it's an evolving nature of the software like performance or scalability that you want to track. So who would do this and what would be the action? So these are just some verbs, action verbs were provided as information in a Confluence page. And so whoever was tracking root cause analysis would then put it in, and some more methods were provided to measure adherence, right? So whether it would be through definition of done, or would you be reviewing the code in Bitbucket, or would you be doing a definition of ready checklist for a lot of these things? So I won't go through this list and read it for you. The slides will be available. But once you have this, right? Once you have this, you have a lot of data, right? So through ODC and orthogonal defect classification, right? The company started by just instrumenting Jira to collect some additional fields and have some defect classification. The focus on the fields that you chose was to see if we can answer 4 basic questions. Did we understand the business needs for which we were writing a solution? Did we brainstorm the solution to the best possible way? And was it done using best practices? And did we use the most effective testing methods, right? And then you objectively assigned a root cause disposition using one of those templates, right? What did this do? It helped to create some sort of a narrative saying a trigger in this origin helped or led to a defect of this type that was introduced and which was addressed by using this type of a fixed category. And that's why my root cause disposition was so-and-so. Okay. We did this over hundreds and thousands of bugs. No more time spent on 5 whys and fishbone diagram, and used Jira for tracking it, which is like prominently used in a lot of places. But the biggest part that I personally am more passionate about and want to talk about is when you start collecting this data, like a week, month, 6 months into it, Jira is filling up with a lot of fields which are capturing this data. So what can you as a quality leader or engineering leader, even a product management leader, learn from this? So we took that data, and I have some sample. The simple defect classification scheme that I showed you, we took 2 of those fields and put it in a Pareto chart, right? So we did some Pareto analysis to say, okay, which type of defects are found in which type of origin, okay? Now look at the clustering that pops up, right? So over a period of 200 defects that we did this, for that period of time, 2/3 or more than 2/3 of the defects were found in the customer prod. Now, what does that mean, right? What is happening is our end users were finding these through their business routines while they were using the software to go about and do their daily business tasks. Maybe the data sources they were using were so unique that led to the problems in the software, right? It's basically telling me that this missed everybody's testing, right? It missed the testing in the engineering cycles. It missed testing in the customer non-prod environment. It missed their UAT cycles. And eventually the end user found it. And that's 2/3 of our problem. So where am I focusing is on these things like data sources and what kind of business routines. I need a better understanding of what the requirements are, what the business needs are, okay? We also, when you dig deeper, you found out that they were using the products in ways that we never imagined they would be using, right? The acceptance criteria that was in the ticket was not, that elaborate. So they were using configuration and the applicability of the configuration, again, in ways they understood better. And we didn't have that information when we were writing the software. right? This was a very powerful tool. Like when you have angry customers who complain about quality, when you have customer visits in your office, or anyone who's trying to focus on quality, if you share this type of data with them, they felt that we were being transparent, and they also realized that this was type of information they can benefit from, because this missed everyone's testing, right? So we would rather focus on that. Another Pareto analysis was a defect type with defect trigger, right? So what this type of orthogonal root cause does is, again, it throws up a lot of data, a lot of numbers, right? And you don't know where to start, where to focus. So you start looking at clusters. What's my top 3 clusters? So my number 1 cluster in this case was, we were finding a lot of defects that were triggered through scheduled transactions, right? So every night there used to be data ingestion, data conversion, and then the system did the auto transaction, completed the transaction automatically, right? Those type of events were the biggest triggers. And what were the type of errors that they threw? Data validation was one, but there's a category we decided for ourselves called functional requirements not documented, but expected to work. So very lengthy, mouthy way of classifying something. But that's the gray area, right? That's the part which is not in the acceptance criteria, but is expected of the Scrum teams and the squads to know about this, right? If you are a team that's worked together for a long time, you should have known this much. This is basic information. This is domain knowledge that you're writing software for. You should have known this. So this is where product owners would, come to us and say, I can't be writing lengthy acceptance criteria or story details for you. This is something you should know, right? Engineering leaders, to some extent, agreed that, yeah, I have an engineer who's a principal who's worked with us for so many years. He should have known this, right? So we created this grouping, and guess what? The gray area had the most number of these defects. Now, again, why was this happening is, again, when you dig deeper into analysis, is you found out that the data ingestion was inconsistent. Different users were doing it differently. The validation, there were some immutable constraints, but the validation on those was being done differently by different modules in the software. So when it worked once, it wouldn't work the other way when there was data ingestion inconsistency. So again, what it allowed us to do is continue this type of analysis, right? You took 2 more, right? What kind of defect origin and defect type? So again, you can see that the automated transactions were the highest, but the second highest was the user initiated transaction. What it was trying to tell me is that the business user intentions are really not clearly known to the engineering teams, whether it's the developer, the product owner, or even if it's a tester. It wasn't clearly known, and configuration and its applicability. The product was highly configurable, so that configuration information was not captured quite well. What about defect type with the fixed category? Now, this is the first time we're looking at fixed category. What were the different choices available, right? As you can see, like the 2 biggest things was the churn in the code was not in the regression area, right? Regression was just 38 out of those 200. A lot of the churn in the code was functional logic. We were rewriting or writing new logic to handle this. So there were really poorly defined boundary conditions and edge conditions where the failures were happening. And then you would have to add that to your logic in the code. There were also some defensive coverage items. So a lot of the bugs failed in a bad way, like they threw Oracle errors or Java stack traces, which means nothing to an end user, right? So a lot of the defensive way, there was no meaningful framework in place to give out meaningful error messages, and there was no default behavior to begin with. So it's, especially in a healthcare company, when you have people who are sitting on the phone and answering questions of all these subscribers, they do not want to see a a stack trace coming up when somebody's record is pulled, right? They do not want to manually adjudicate claims or process some information or enroll a member into a health plan. So if they got blocked, we should have at least allowed them to manually go ahead and use some other options. So there should have been some default behavior in there. So that wasn't there. That's why the defensive coverage cases were high. Null pointer exceptions, assertion exceptions. You should be able to put defensive coding in place for null pointer exceptions. And then just to keep going with this, with the fixed category and defect trigger, we started to see that the product was being used in very ingenuine ways by our users. There were a lot of users, and the product was really not restricting the users from using it in unintended ways. So again, we could have benefited from more real world configuration and process improvements. So this process, eventually the leaders used this, and in 2021, we had 20% fewer bugs than 2020. And in 2022, we were on course to have another 20% fewer bugs than last year, right? So the most common causes, we weren't repeating the mistakes. Everybody was looking at these types of clusters. The good thing about this Pareto analysis is if you address your top 3 concerns, the next top 3 would bubble up, right? And then you start working on those. Right? It clearly told us that let's not put our focus on DevOps activity or data analysis kind of defects. Those are very few. Let's focus on some of these other ones where functional coverage or defensive coverage should not have, taken that. How are we doing on time, Kathleen?
You have about 15 minutes.
I have 15 minutes. If you're interested, like over a period of time, what happened was we modified the defect classification scheme, right? So introduced a new field called last modification. And like as we were learning more about how to improve the software, why was this happening was all the engineers were starting to complain that the bug I am fixing wasn't written by me. Code wasn't written by me. I joined this company now. It was written 10 years ago. It's in the legacy code or inherited code, right? So I'm being asked to do a lot of this work. How do I write a root cause for it? How do I think about what someone else could have done better, right? 10 years ago, 15 years ago, when they first started this. So we created a new JIRA field called last modification. And it had 3 entries. When was the code that you're changing, when was it last touched or last changed, right? Less than a year back, between 1 and 2, and more than 2 years back. And we would capture the file name, the line numbers, the last modified date, and we would put it in some kind of a category. It was very simple. Again, tried to do everything real time in process kind of data gathering. You go to Bitbucket while you're fixing the code, you already have to select a fixed category. The lines you're changing, just right click, select them, right click, check history. Bitbucket will give you the history. All you have to do is just capture it in there. Now, what did it tell us, right? 60% of the bugs that we sampled, the code broke, which was legacy code many years back. And developers really don't like to work with someone else's code. So how do we focus on 60% of the legacy code issues, right? Again, so everybody collectively sat together and started to talk about why does a seemingly dormant area of the code has problems now, right? 3 years from now. What are our end users doing differently now that they weren't doing 3 years ago, right? Am I going to go back and look at my acceptance criteria from 3 years ago? Nobody wants to do that, right? What was the decision made, right? Am I going to just fix this for now, and let it surface up again, or I'm going to, spend more time on redesigning, refactoring the code as part of my bug fix, right? So I want to leave some time for us to go through questions, but if you start seeing a cluster where the bug was introduced by code written less than a year back, you got to go focus on your engineering practices. You got to go back to your governance model, your check for adherence, go do more Pareto analysis, form the RCA data, find out the right improvements through the root cause analysis gathered, and see if this can be stemmed. Where is this coming from? If it's between 1 and 2 years back, again, the question was, why is it happening now? Can we go back to the product and say, did you realize that they were going to start using this a year later? In this, they were going to add a few more data sources. Did you know about this? So they can go back to our customer and say, hey, everything worked fine for a year. It's starting to break apart now. What haven't you told us? Right? So we would like to go back and create newer epics so that we can fix this and not treat it as a bug. And if it is more than 2 years back, right? Again, it's a collective team decision to focus on refactoring the code, redesigning the code, make it better, wholesome way. So I think that's the end of my slide. So what do we have for questions? Yeah. So these were made mandatory fields. Oh, sorry. Yeah. The question was, do we capture the 5 items in our defect classification scheme, the origin, trigger, type, fixed category for all JIRA issues or just a subset, right? So this was for everything, all defects, all tickets of the type defect. And these were mandatory fields to be filled out, yeah. Yes, so what Ram really talked about in his, yeah. So what he said is tailor these to your organization, right? So I sat down with an extract in a spreadsheet of some of our defects and started to create clusters and look at what were the keywords that were always popping up in some of the comment fields, in the subject field, in the description field. You can use a word generator to find out which ones are most prominently coming up. And that led to this scheme, which was then socialized with the rest of engineering, saying, I would like to capture these for these values. And then everybody collaborated and talked about it. And that's what we started collecting. Yeah. Yes. So like the goal really was on reducing incidents and preventing bugs, right? Bug avoidance was a major part of this, right? We were looking at thousands of incidents coming in through Salesforce and hundreds of bugs. That's a lot of time engineering has to spend away from writing awesome features, right? So how do we bring it down? And nobody likes to work on bugs for a long time. So that's more beneficial, right? Yes. Thank you for sharing. Yes.
And secondly, the risk you actually do the slide fixing.
Okay. Bob, right? You're Bob, right? Your name? Robert, right? Big fan, Robert. I've been reading a lot of your articles. Yeah. Yeah. So I know. Let me answer the second part first. Is the fixed category was, again, designed in a way to see what the engineers in this group or this organization were doing wrong, right? I'll give you an example. We were capturing a lot of null pointer exceptions, right? So which led to a category called defensive coverage. Now that they fixed and the null pointer exception type of defects went down, we're no longer using defensive coverage as in our top cluster, right? Something else is popping up in the top cluster. So it doesn't render it useless after we fixed it. It's really for the engineer to say, where am I focusing on, right? Which was done using this pyramid, the hierarchy of controls. I am focusing on, let's say, for example, making it hard for the user to do the wrong thing, right? Which is why I should not allow null values to begin with, right? And that's why the category was introduced, right? And can you repeat the first question? Sorry. Can you repeat the first question? Yeah. Okay, the question, right. So the question is coming is how do we know that these causes were orthogonal, right? They were parallel, right? And again, I was inspired by Ram's paper and his website on this, where he did a lot of this work. And again, why am I calling it orthogonal right now is because it is completely part of my process. It is not part of, it's not something special. I'm not doing an RCA meeting. I'm not having any calendar invites for participation. This is real-time, in-process defect gathering used by engineering leaders to do defect profiling, use that defect profiling to do analysis using Pareto charts to focus on what's critical for our organization to fix in terms of software quality. So that's why I would say this, that's why it's the orthogonal process, because when you talk about quality with a lot of people, right? People would say, we measure quality through escape defects or through code quality or code coverage, code complexity, a lot of those things. This is completely different in that sense, right? We are not using those metrics or defects per 1,000 lines of code. That's because I'm creating a category that I will classify my defect into, right? So now when I look at each defect, right, I know for that defect the origin, the type, the trigger, and the fix category. That's why it's a classification, right? And that is my profile of each defect. Yeah. Okay.
Two questions online too.
All right. All right. Go ahead.
Experience in a person's playing.
Yeah. Okay. So the question in the room was, how did we, figure out the human element, make sure there was no finger pointing in all of this? So that was my opening statement, to say that RCA meetings aren't fun, right? There's a lot of defensive mindset, defensive approach coming into, like people coming into a room thinking about this being a blame exercise or a finger pointing, like you said. So we wanted to get away from those negative perceptions of root cause analysis, right? And that's why I make this based on a simple philosophy that a defect in the software is a defect in the process, right? So So the templates that were provided gathered the data, and they were able to use it to provide root cause. And we evolved over a period of time to add the root cause reasons that weren't there. It really didn't lead to any kind of emotional human, because you were doing this at any part of your day, because you could be closing a bug any day, and you were just gathering You're just putting in the fields in Jira, right? The managers were then looking at this, and it's their job to go and see what were the tickets I worked in the sprint. Let me go look at the root cause, make sure it's meaningful. And they made sure that we weren't collecting useless data, right? Everything was going to be useful when the leaders looked at it. Let's go to some questions in the room, in the Zoom. Yeah. The question was, what about test coverage improvement from this practice? Yes, the detection improvements were really focused on test coverage. You can add, if you were using this template, you can add your process and your action item in there, right? You could have an improvement saying, going forward, as part of validating my story, the test engineer will check Sonar reports for code coverage of unit and integration tests being more than 80% or higher, right? That could be your improvement. So that is possible using this. And the second question is, did you get any pushback from the team to fill out? Did you have training or other to roll out or help get this process in place? Yes to all of it, right? We did have some pushback because this was new. Nobody had heard of this. Nobody had done this before. So a lot of socializing went into discussing it with different groups. We sat together. We were inclusive of everybody choosing the pick lists that you would like to do. We did a lot of nomenclature type of which words people got emotionally distraught or which ones they didn't like. We removed those. And yes, there was a training every 6 months. We would do training because new engineers join all the time. So they should know how we're doing this. And this was done at scale, right? So when you do 5 whys, you're looking at one incident or one bug. And what happens is you can't change your overall systemic quality by looking at one of these things. By doing a clustering through Pareto, now you know what systemically needs to be fixed for the teams. There was pushback initially on why this would take a lot of time to capture. But when you show it real time, we did it in a staging Jira, that how quickly you could choose these lists, right? You were done in minutes, right? We're talking about two additional minutes of your time and not a full meeting with 10 people in the room. So once you've shown that, the pushback also went away, and we were good from that point onwards. Yes. It probably took me a month looking at what Ram put on his website, some guidance from there, and then trying to apply that to what's happening in this healthcare company where I was working for, right? It took, again, spreadsheet, reading through a lot of spreadsheets. In a spreadsheet, you can collect all the short descriptions or descriptions of defects in one field, put it in a word generator, and then that word generator throws up maximum occurrences of each word. And then I use that to say, okay, I showed that as well to our team. So that took some time to figure out where do we focus, because the initial recommendations were much different than, sorry, maybe this is better. The initial recommendations were much different than what this was finalized to. This was fine-tuned. And then we added categories like, data validation or functional requirements not documented but expected to work. Yes. Okay, the question is that with so many defects in the backlog, does this impact our future development activities? In a way, it does, because unless you've gotten to a fixed category, you're not filling out these fields, right? So it's on a separate tab called root cause analysis. that sort of gets triggered when a defect moves from coding complete to test complete, and it's ready to be accepted or demoed. That's when you have to fill this out, right? So the tech lead would do it. So until you knew a fixed category and you had fixed it, you wouldn't be doing this. So obviously the backlog of bugs would impact the future because you do not know what improvement action is going to come from those yet. So these were real defects. So because they started in the field, they came through the support channel, and most companies would have now tier 3, maybe they call it ESUP or sustaining engineering, where support cannot solve those problems. So they have to bring it to engineering. So these were those type of defects that were flowing into engineering because nobody else could resolve those.